So there are many things in the real world that grow faster as they grow larger or decrease slower as they get smaller. These types of phenomena, loosely speaking, are known as exponential growth, and decay if you're talking about decreasing. Today's lesson, we're going to look at both growth and decay. So let's look at the first one. The number of people who have heard a rumor often grows exponentially. So consider a rumor that starts with 3 people and where the number of people who have heard it doubles each day that it spreads. So the first question says, why does it make sense that the number of people who have heard a rumor will grow exponential? Well, the more people who know the rumor, the more who can spread or tell to the others. So the more that know, the more that tell. So we're going to fill in the table below for the number of people, N, who knew the rumor after it has spread a certain number of days. So we know that it's doubled each time. So from 3 to 6, so 3 times 2 equals 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. So we'd like to determine the number of people who know the rumor after 20 days. But to do that, we need to develop a formula to predict N, the number of knowing the rumor, if we know D, the number of days it has been spreading. So for the following number of days, fill in how you calculated your values based on extended products using the number 2. So for day 0 is 3. For day 1, it's 3 times 2, which is 6. Day 2 is 3 times 2 times 2 again, which is 3 times 2 squared, which is 12. Day 3 is 3, we're going to erase that. We're going to take the answer from before, which is 12, times 2. That's the same thing as 3 times 2 times 2 times 2 again, which is 3 times 2 to the third, which is 24. Day 4 is 24 times 2, right? Which is the same thing as taking the 3 times 2 times 2 times 2 times 2, which is the same thing as 3 times 2 to the fourth, which is 48. And finally, 48 times 2 is the same thing as 3 times 2 times 2 times 2 times 2 times 2, which is 3 times 2 to the fifth, which is 96. So you'll notice we have a 2 here and 2 to the second power, a 3 here and 2 to the third power, a 4 here and 2 to the fourth power, a 5 here and 2 to the fifth power. So using the pattern you developed in A, write a formula giving the number of people who know the rumor if you know the number of days. So the number of people that know the rumor is 3 times 2 to the number of days. So this is how many doubles. So how many people would know the rumor after 20 days? So what you're going to do is you're going to put 20 in for D. So N equals 3 times 2 times 20. Well, 2 to the 20th power is a really big number. Then you multiply that by 3, and you end up with 3,145,728 people. Exponential growth can obviously be very, very fast. Assuming our equation from B holds, how many days will it take for the number of people knowing the rumor to surpass the population of the United States, which is approximately 315 million people? So let's try 25 days. Well, at 25 days, we end up with 100,663,296. So not quite 315 million. So let's try 26 days. Well, 3 times 2 to the 26th power is about 201,326,592. Really close still. So let's try 27 days. So 3 times 2 to the 27th power, which becomes 402,000,000 653,184. So it's going to take about 27 days to surpass it. The next one, Helmut from Finland, is heading towards a lighthouse in a very peculiar way. He starts 160 feet from his lighthouse. So you'll notice the helmet is right here, the lighthouse is right here, so 160 feet. On his first trip, he walks half the distance to the lighthouse. So on his first trip, he walks about 80 feet. On the next trip, he walks half of what is left. So half of what is left, so he walks 40 feet. On each consecutive trip, he walks half the distance he has left. So half of 40 is 20, and then half of 20 is 10, and so on. So this is our first trip, second trip, third trip, fourth trip. We're going to model the distance d that Helmut has remaining in the lighthouse after n trips. So what you're really doing is you're dividing by 2 each time. So first trip, he walks 80. Second trip, 40. Third trip, 20. Fourth trip, 10. So we're really multiplying by 1/2 or dividing by 2 each time. So each entry in the table could be found by multiplying the previous by what number? Well, multiplying by 1/2. So it says multiplying, so you have to think of it in terms of 1/2. So like in number 2a, we want to see the process as repeated multiplication by 1/2. So fill out each of the following pattern. So at 0, it's 160, right? Because that's our starting number. At 1, it's 1/2. And you could put an understood 1 here because we need that 1 to show up somewhere, which is 80. And this is the same thing as 160 times, I'm going to rewrite that because that's kind of hard to see. So 160 times 1/2 to the second power, which is approximately 40. So again, we have our 2 and our 2. The next one is going to be 160 times 1/2 to the third power, which is 20. So again, we have our 3 and our 3. And the last one is going to be 160 times 1/2 to the fourth power, which is 10. So we have a 4 and a 4. Some of you are probably looking at this and going, I don't understand what it means to take a fraction to a power. So up here, I'm going to write what it looks like. So if I have 1/2 to the fourth power, that's the same thing as 1 to the fourth power over 2 to the fourth power, which becomes 1 over 16. So what do you do? How do you get 160 times 1 over 16 to equal 10? Well, all you're doing is you really take that 160 and you divide it by 16 since it's in the denominator. So that's just kind of a quick little tidbit for you. So based on C, give a formula that predicts the distance d that Helmut has left after n trips. So his distance is 160 because that's where they started, times 1/2 because that's what's being multiplied each time, by n, so how many times that you are multiplying by 1/2. So how far is Helmut from the windmill after 6 trips? So we're going to find d of 6. So 160 times 1/2 to the 6th power. So remember, you're taking that 160 and you're multiplying it by 1 to the 6th power, which is 1, and 2 to the 6th power, which is 64. So really what you're doing is 160 divided by 64, which equals 2.5 feet. So that's how far he is from the windmill at that point after 6 trips. So Helmut believes that he will reach the windmill after 10 trips. Is he correct? So what we're going to do is we're going to plug 10 in for the n and see if it's true. So is d of 10 going to be at least 0 or equal to 0? So 160 times 1 over 2 to the 10th power. So 1 over 2 to the 10th power becomes, 1 over, so 2 times itself 10 times is 1024. So now I'm going to take 160 divided by 1024, and I end up with 0.15625 feet. Is that equal to 0? Nope, he will not reach the windmill. So he will never reach the windmill. Why? Well, he's never going to reach the windmill because there will always be half the previous distance left. So there will always be half the previous distance left. So why is the domain of the function only the whole numbers? So whole numbers, remember, have to be numbers starting with 0 and going up from there. Well, the domain is the input, so the numbers that you're putting in for the little numeral n. So Helmut only takes whole trips. He only takes whole trips, right? So that number you're putting in is what trip number? You can't take a half a trip or a fourth of a trip. So he only takes whole trips, so that's why the domain is only whole numbers.